This is going to be the last lecture PowerPoint we do for this semester. We are talking classes. Everything comes together here, including functions, conditionals, loops, collections, all of that. So when we talked about functions, we were building our own functions last week. This time around, we're building our own data types. That is the essence of classes. That is the essence of object-oriented programming. So we're going to get into exactly what object-oriented programming is. We're going to talk about classes and objects. We're going to talk about members and methods. These are some terms that are absolutely necessary to understanding object-oriented programming. We're going to talk about dunder methods, which is a little bit more specific to Python. And then we're going to talk about some of the pillars of object-oriented programming. There are 5. We are going to talk about 2 of them, composition and inheritance. There's a lot to talk about here, so let's get started. So, what is object-oriented programming? Well, up till now, you have learned about singular constructs within programming as a more grounded thing. You know, we've been focused solely on what is an if statement, what is a function, what is a for loop. Now we're going to be talking about more of a paradigm. Object-oriented programming is more of a general idea, although it does center around some constructs, namely classes. The point of object-oriented programming is to represent real-world objects using programming code. So if you think about any given object in the real world, it has some qualities and it has some things it can do. And we can represent those in our code. And the reason these came about was because of massive monolithic pieces of code similar to the ones that you've been writing in this class up till now, but on a much, much more massive scale. Back in the 70s and 80s, these were getting increasingly huge and complicated and error-prone. Not to mention all that work that was going into these massive programs wasn't really reusable at all. So object-oriented programming came about as a means to streamline our work process and introduce code reusability. So, OOP breaks code into reusable pieces, each representing things in the real world. That is the gist of what you need to understand as far as what object-oriented programming is. There are a ton of concepts within OOP that we're going to talk about. So, most programming languages, just so you know, most modern languages support object-oriented programming. The original C language is an example of a popular language that does not use OOP. But Python, Java, JavaScript, C++, C#, all of these, Ruby, I believe, all use object-oriented code. So, let's get into some terminology and talk about the difference between a class and an object. Simply put, a class is the definition of what the thing is in a broader sense. These aren't given existence within your code, but rather serve as a template for objects that are created using that class. So you have member variables that describe it, and you have methods that are defined that use it. But the methods are not really given any concrete value. Rather, it is objects that give those variables meaning. And an object has a more physical presence within your code. Another key difference with a class, you can only define them once. Once you create the class, you've done all you need to do for it. When you create an object, you can create tons of these. You could create a list of objects of a class that you've created. And this is extremely common and will be something featured in our second class project. We are going to create a list of objects. So, to shorten, a class is a logical entity that explains what objects of that class look like. An object is an instance of that class that gives concrete meaning to the blueprint specified within the class definition. So, moving on from that, we talk about members and methods. First off, a member is a variable contained within a class. These are all nouns. A car has a top speed. It has a fuel mileage. Things like that. So, a member, think of members as nouns. Another example here, student has an ID number and date of birth. Whereas a method is a function. It is a verb that explains something that class can do. For example, a car can start, park, be filled with gasoline. A student can enroll in classes and purchase a meal plan. And other things like that. Signing in, signing out, querying a database. All of these are examples of methods. There are also class members that exist that will affect the class itself. There are cases where you might create a variable within a class that has a value for the overall class. These are often referred to as static. And we can access anything within a class, at least in Python, using dot notation. So if you have a car class and you want to reference a static variable within it, you would say car dot whatever that is. If you had, say, a student object called James, and James has a student ID number called ID, you would refer to it using james.id. For the most part in this class, almost exclusively, we will be working with instance members. We will not be working with anything static, so you don't have to worry about referring to things by class name. Just worry about referring to things by object name. So there's also the fact that instance methods, in Python, the very first parameter needs to be self. This is ignored by the user, but it is a requirement in Python. Now we're going to quickly talk about dunder methods. We have a few slides to discuss these. A dunder method is also called a magic method, and these allow your classes to interface with the operators and functions that we've been using up until now. Things like print and using the equals operator, using the double equals operator to compare two objects. Dunder methods are what we use in order to enable our classes to interface with them. Other programming languages like C++ will allow you to overload operators and such to specify a particular behavior with that operator. Python doesn't allow that, so as a workaround, we have dunder methods. The term dunder comes from double underscore. As you can see from these two examples here, this is dunder init and dunder repr. These begin and end. I repeat, they begin and end with a double underscore, hence dunder. So now let's look at a few dunder methods and see what these are like. So dunder init. Pretty much every class you create is going to have a dunder init. In other words, initialize. And this is going to work as a class constructor. That constructor is going to accept some data that you're going to use to define the qualities of that object. The dunder init method does exactly that. It is called automatically whenever an instance of a class is created, just like a class constructor. Dunder repr, on the other hand, returns a more official, more programmatic stringification of an object. Here you can see a not too great example of it. This would be more akin to something you would use in the dunder string method. This is more of a human-readable, colloquial type of thing. And that's more the territory of dunder string than dunder repr, although I have seen people use these two interchangeably. They both technically do the same thing. they return a string representing an object of a class. But generally speaking, repr returns a more official representation, whereas string returns a more something that's a bit more for human eyeballs. And now we have a bunch of others here that I want you to look up and understand. Of course, we have dunder string, we have dunder del or delete, we have dunder set attr or set attribute. It sets object.name to whatever value you give it. Dunder add uses the plus operator. Dunder len is how we get the length using the len function. And dunder eq or equality, this checks if the two have the same value. So you can find a bunch more of these at the link provided here. It is very important that you understand a lot of these for Python, or at least have a handy reference, because you're going to need some of these. So that's going to do it for the overarching the overview of this topic. When we come back, we're going to do some examples, some very basic examples working with classes, and then we are going to talk about these concepts, composition and inheritance. I don't want these to be in the overview. I want these to be their own separate videos after we do some basic examples. So stick around for that.